Good evening, friends. Welcome to Eason Academy. We are into embedded system programming. On that, we are discussing about C language and session 6, and we are going to discuss about arrays and strings. And first, let us discuss about arrays. Okay, so what is arrays? So C have a special facility to declare. We declare int A, B, C. That means that inside the memory, it allocates one space for A. The size will vary. Depends on integer means, let's say 32-bit. Then it allocates 4 bytes. For B, it allocates 4 bytes. For C, it allocates 4 bytes. That's the way it's C. Your C compiler allocates the space. And we call this as address. And what is inside the 4 bytes is called A. That's called, we call variable. It's a variable and the address. That's fine. Now, if you say that int A within the close bracket of 5, then the system allocates the memory 5 spaces. Each one is 32-bit. That means that it allocates 5 into 4, 20 bytes. 20 bytes. This is A of 0. If you say 5 means start with 0. A of 1. A of 2. You do not have to declare like that int A of 0. A of 1, like that. And another important thing, let me explain to you now in C. Int A1, A2, AI. There are 3 others, A1, A2, AI. What the compiler will see this it takes as a symbol. A1. It takes A2 as a symbol. It takes AI as a symbol. So if you say I, let's say I have another variable called I is equal to 3. A3 is equal to 5. Then system will not apply the I here. This will not become A3. You cannot separate the variable. AI means AI. A and I cannot be separated in, but it's possible if you do like this. If you do like this, int A of 5, comma I. Now I say I is equal to 3. I can say A within bracket I is equal to 6. Now what happened? A of 3 it takes is equal to 6. That's what the meaning. Now here it writes 6. So understand the difference between AI and A within the close bracket I, square bracket I. This is called array. Array means he allocates space for more. Let us say I can want 100, I can say 100. 1000, he allocates 1000. That's the advantage of C. That's the power of C. I can allocate 1000 spaces in one command. You understand that? Is it clear? So the trick here is always follow the rules. That's the most important thing, is follow the rules. What is the rule? Rule is very clear. I told you while defining character, CHAR, minus 128 to plus 127. I say CHAR, I is equal to 129. This is wrong because CHAR means minus 128. Don't try to declare other numbers and say what will happen. That is not right. Once you become an expert, you can ask those things. That's not now, initially. Same way, if I say here A of 5 means he declared 0 to 4. If I say here A of 5 is equal to 25, what will happen? We don't know. How the compiler will behave, we don't know. That is possible. If you say unsigned character, you can do that. But if you say unsigned character, I is equal to 280. That is wrong because it can go only up to from 0 to 255. You cannot go to 280. Okay, that time you have to define as a integer. Sorry, short or long or anything, whatever it is. So understand here, when I say the array, it's only 0 to 4. One less always because it starts from 0. Don't try to do this. That is not acceptable in C. It may not give error. It may not give error. Okay. It may work, may not work. Let us see the thing now, right? Let us check that on our code. Let me share it now. Let me share the screen. One minute. Okay. Let us write a small program now. Okay, I've written a thing on x of 5. What is allocated is only 0 to 0 to 4. Okay, but I've written here 5. That's a problem now. Now what happens? Let us save the file. See, that's not given error. See that I've given 5 only, but I've written here excess. Still is not giving error. Now I execute it. See, he is also print 20. All right. I've given 20, I got 20. Okay. So you think that this is right. Okay. But this is not always true. So this is not, let us say I give here A, B. A is equal to 5. B is equal to B equal to 6. Okay. Now I print A, comma, B, comma, X of 5. It's fine now. In this case, he's not giving error. He's giving same 5, 6, and 20. Okay, now let us give different number here. 6. That's the problem. See, you don't know how he is allocating the variables. And see here. Now we got 5, 20, 0. See the result now. I given 5, 6, 20. I got 5, 20, and 0. Now B has been 6. Now B got changed to now you see here. I supposed to get 5, 6, and 20. But I'm getting 5, 20, and 0. Now B becomes 20 because you are correcting some other variable. So this is not acceptable. This will, you may not know that how this guy will behave. Your program will not work. No. What I'm trying to tell you is that very important information. I want, that's why I showed you now. Okay. Why I showed you this problem is this one you are writing 20, it is overwritten the B value, variable. Okay, that's why I want to show you that. Okay, now B becomes 20 and this becomes 0. X of 5 becomes 0. So let's do that. Let's go back to the thing. Then I'll explain to you that why it is. No, why? If I explain to you something, it's very meaningful. The thing is that most people do this mistake. That's why I wanted to show this. People do not understand the seriousness of this particular issue. Even big problem, big people, big driver people, those who write thousands of line code, 10,000 line code, by mistake they do that. They write by mistake this one. Declared 5 and they're 5. You will never know that how this guy will behave. Okay. Is it clear now? That means that if I have an array, it declares the thing, same thing. The array can be any way. You can never see a character array. That means that I allocate 8 bits. I allocate 1 byte. That means that I get about 5 bytes. 5 into 1. You may have a short int B of 5. Then we allocate here 5 into 2, 10 bytes, 2 bytes each. Because you have a short, you can say a long int C of 5. Then we allocate 40 bytes, 5 into 4, sorry, 20 bytes. If we say long int D of 5, that means that we may allocate 5 into 8, 40 bytes. Understand now? You based on the type, declaration type, the array will declare. There's nothing, it's not possible for you to declare 2 of this, 3 of this, is not possible. If you choose array, it will do the same type. It will have a, there's no mix match, it's not possible. So now I can store anything on the array. Now we have already discussed. When I say int a, I can say a equal to a number 10 or a equal to 0, 10 octal, decimal, octal, or a is equal to 0x10, hexadecimal. A equal to, within quote, a, you call symbol, and a minus 5, negative, or a 0, b 1100, 1110. Everything is possible. This is a binary. Understand? So everything is possible. You can assign any value here. Now let us take our case. This is all simple. We'll take our case symbol. Symbol is generally allocated for only 8 bits. So generally we don't use, to allocate a symbol, we don't use integer, we use only char. Because ASCII table have only normally 0 to 127 and the extended ASCII. ASCII is 128 to 255. So maximum 8 bit. That's why we always use char to, so I can say that a, and I say a equal to, within quote, a. Now this a is a symbol. He goes to refer to the ASCII table. In the ASCII table for a, the value is 65. So what is stored in the memory is 65. If you do print of %d, comma a, you get 65. Let us see that. Let us see in a minute. Then we, before we proceed further, then let us see that. 1 minute. Let us see char a. Once you see the thing, then you will not have a problem. Now a is equal to, within quote, a. Comma a. Am I right? I'm just printing a. So I compile it and run it. I get 65 because I asked him to print the decimal. So he, location A have 65. But if I tell this printf, hey, print as a character, okay, don't print the ASCII value, print the character, then he will take the 65, say A. But it doesn't matter that you have to write only A here. See that I write here A equal to 65. See here. I write A is 65. Now let us see what I'm getting. I'm getting A. Now I say that 0x 41. Sorry, 0x 41. Okay. Now let us see what I'm getting. A. You see that. If I write 41, whatever it I'm getting the same thing. Now I see that I'm writing here 0101. What do you expect now? When you write 0101, what is 789 don't show? ASCII value, everything will show. I'll discuss about that next. So somebody has asked the question that the question is the question is that why ASCII value of 789 don't show on the output screen? Yeah, it will show. It will show everything. I'll show you that. Now you see here, I've written 0101. I compile it. No errors. Zero error, zero warning. If you run it, what value you see? You expect it is A. Same A is showing because this is octal. This is octal. So anything you write here, it doesn't matter what you write. Okay. Now I write here within quote A. Now I write here instead of A, I say scanf now. Percentage C. I reading a character. Now and A. See now here. Like so far we discussed percentage D. Now I'm discussing percentage C. I run it. I execute it. I press A. I get A. Simple. But if I do here, percentage D, execute it. I get here A. I enter A. But see what I'm getting. 65. Yes, 0101 is makes 65. That is octal. 0 start with octal. Okay, that we already discussed the number system class. The second class of assignment, I've discussed about 0101. That is 1, 8, 64. So 64 plus 1, 65. So now you have seen it. Now let us try to do other one. I declare now simple program here. A of 5, 4, comma, A of 4. I say A of 0 equal to E. A of 1 equal to C. A of 2 equal to E. A of 3 equal to N. Am I right? I've written, I've stored all the 3 in 111 each location. I can share that screen and show you the other one. I can write there also. Okay. So now you can print here A of 0. Now you see here percentage D, percentage C. A of 0, A of 1, A of 2, A of 3. Am I right? So I've written everything on one line. A of 0 to I initialized. So let me draw it. Let me do it here. What I'm doing now. So what I'm doing now is I declared CHAR A of 4. That means on the memory, I have declared A of 0, A of 1, A of 2, A of 3. Am I right? Now I stored here E, C, E, N. Not exactly the characters, all ASCII value. Corresponding E will be 65 is for A, B, C, D, E. So if you do like that, 66, 67, 68, 69, 69. Once again, this is 67, 69, some 76 or something. So so many things are there. Now when I'm printing one by one. Now I just do the thing. Now it is printing ESON. Understand? So to print a ESON, I have to, this is the only way we do that. Am I right? To print the ESON, this is the only way. Okay, is it clear? Do you see the screen now? The screen is visible to you? Now people have found a nice method. Instead of doing like this, instead of initializing like this, they thought you can initialize this way. Simple way. Equal to E, comma, C. Am I right? Is it clear? Now is it clear? I've done a better initialization now. This is a second level of optimizing the code. If we do like this now, if we do here equal to within quote, I write the code here. Okay. Now let us compile the code now. Now I print it. I got ESON. Now it's better. Then people thought, how do I make things simpler? Then they thought that, hey, don't do this one. Remove this and put double quote. Understand now? See here. Now instead of single quote, I change it double quote suddenly. Now, if I compile and print it, Eastern, it's printing. Now they wanted to avoid this. They wanted to avoid this. They don't like the way of writing so many C's. Now what they have done is they have put a nice, wonderful method. That is the beauty of this system. You can remove the whole thing and you put percentage yes instead of C. And A of 0. See, I'll explain this now later. What is and A of 0? Now let me compile and run it. See what I got now? ECEN. Afterwards, I got some new junk characters. You know why? I'll explain to you now that one. I'll explain this one now. Then I'll come back to the screen. Okay, let me explain to you now. What is this problem? Okay, let me go back. Let me stop this carrying. If I explain to you this, you'll be able to see understand the code. Let me put it on the same Zoom mode. Then it'll be easy for you to read it on the thing. Let me put this one as a mute. Okay. Try to understand. I have written now CHAR A of 4 ECEN. Am I right? This is what I did. Double quote. Unfortunately, if I do this, sorry, not unfortunately, if I do this, then the compiler, what it does is, in a memory, it allocates 4 spaces. A of 4, A of 0, A of 1, A of 2, A of 3. Am I right? Let me, since I put a zoom, I just wanted things to be clear. So I made the zoom. So the zoom is making it A of 0, A of 1, A of 2, A of 3. Now it put for E here, C here, E here, N here. That's fine because you have 4 allocated and 4 characters. Everything is fine. But when you do printf percentage yes, I've given now and A of 0. What it means? A of 0 is this and this address. So I've given this, maybe the address could be 1000. I've given 1000 to the printf. Since I've given percentage yes, the printf thinks this is a string. What the printf does is, he go to 1000. What is there? A, E. Print it on screen E. Then what is he automatically increment to 1? What is C? Then automatically increment E and automatically increment N. Understand? Now it print ECEN. Unfortunately, the printf does not know when to stop. Then it goes to the next character, 1002, 1003. Then it goes to 1004. That it checks. So it keep on going till it finds 0. That's why you got the junk characters. When I showed the previous screen, you got the junk characters because it does not know where to stop. You see here, you got the, sorry, I'm not sharing. Sharing. Yeah, you saw here, you see here some E on the top, exclamatory mark and on. That is because the printf does not know when to stop. So what the Dennis Ritchie did was he defined the string is a set of characters. What is string? String is nothing but group of characters. End with 0. End with 0. So it is a must. The moment you use percentage yes, you should make sure that this should end with 0. That is the reason what the compiler does. If you put ESN, you should allocate one space extra. Now I'll do that. Now I write the same program. Now you see that. The same program, I do a small change now. Then you will see the difference. Now how it will print. Instead of this, I put here 5. Now I build it, execute it. Now you see ESN, it's coming perfectly. You write anything here, not only ESN. ESN welcomes you. You write any program. Okay, but you have to count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. For 0, I allocate 18 spaces. Now I run it, compile it. See, ESN welcomes you. But compiler did one more advantage to you. He said that, hey, don't do this, man. You give me just the 2 brackets. Enough. I will count for you. So the 18 will be counted by the compiler itself. Now you see here. See, ESN welcomes you. You do not have to set the number. They given one more facility. That is what the trick here. That is what the trick here is. They say that you do not have to say here in the memory. You have 4 locations. A of 0, A of 1, A of 2, A of 3. Now the address is I told you, and A of 0. That's the address. But what the C said, don't have to give this. You just give A is enough. If you have an array, A, you give the name of the array is enough. I'll explain to you this tomorrow in a pointer class. Right, till that time you accept. See here how small I made it. This is what a small string program. Understand now? See, everything is working fine. No, storage does not get affected. If you do like that, if you do like this, if I write a thing like this, this is wrong. I'll tell you one thing. Please understand this. If I say CHAR A equal to ESN, this is fine. This is acceptable. Let me write CHAR A equal to ESN. If you write the statement, the compiler will count 1, 2, 3, 4 characters, and he will allocate automatically 5. The 5 will be put by the compiler. Please understand the thing. The 5 will be put by the compiler, not you do not have to specify. But the other one is wrong. If you say here CHAR A of like this, then you say A of 0 is equal to 5 E. Then the compiler will give error, because here it knows how much allocate. The moment you say like this, he does not know how much allocate. So this is wrong. This is right. If you do a null bracket, then you have to give a string. Otherwise, he will not know how to allocate it. So please don't do this. If you do only this, you should give 5 or 4 or whatever it is you want to allocate. So a string, but also this is wrong. Don't do int A equal to string is wrong. A string has to be only a character as per definition, not an integer. Don't use integer for string. String is a set of characters ends with 0. That's called string meaning. Nothing, it's not very difficult or anything. End with 0, that's all. Why? Because everybody handle it. They will start, you do not have to specify the length. When you specify a string in a memory anywhere, Ethan, welcome. And you give only starting address, 1000 to printf. He goes automatically one by one till it gets a 0. Because the printf knows that if you put %s, then it's a string. %s means string. So string should end with always 0. Okay. So this is what all about string. So never use in a string. Let us give a thing now. Let us give you the small example now. I say here int. Okay. Now I given a int. Now I compile it. See here, error. He say array of inappropriate type initially with the string. This is wrong. You can use only int. Char. So please understand, the things are very simple. So let me go to the board back and explain to you the thing. Then you will understand that what is this. Please understand, if you say char a of 5, then 5 locations are allocated in the memory for you. That's it. If you say within bracket, you say 1, 2, 3, sorry, like this. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5 are written here. But if you write here within quote 1, 2, 3, 4, 5 within single quote, then the equivalent of ASCII for 1, it is 49. For 2, 50, 51, 52, 53. Please understand the difference. If we don't put the single quote, then the value is allocated. If we put the thing, but I can do this also. If I put like this, within double quote, 1, 2, 3, 4, 5, then what is stored in the memory is 49, 50, 51, 52, not 1, 2, 3 decimal. Please understand. Because a string is nothing but group of symbols, not numbers. A string is nothing but group of symbols, not numbers. In this case, the 1 is taken as a symbol. Not 1 is not taken as a integer. Please understand. So you have to, if you wanted to do print, if you do printf now, see if you do like this, if you do printf %d, comma a of 0, you will get 49. But if you do here, a of 0 is equal to a of 0 minus 48. Then you will get 1. To convert the ASCII into the thing, you need to subtract the value. Understand? The 48, because 48 is equal to 0. Simple. I know that I've not explained this much depth. You would have got confused, but the confusion should be there. When you start writing a program that is from the problem 36 onwards, we start using that. Till that time, don't worry. If you are within the 35 problems, don't worry about this string of arrays or anything. As I mentioned to you, this triangle, the 4, declaration, assignment, operation, and decision making. These 4 are sufficient for the 35 problems. And also now I'm sharing a lot of problems in the net, level 1 and level 2. Try to do as many problems as possible. Then we get into the functions. Learn to write functions. Then get into the 3. Strings, arrays, strings and pointers, which we're going to see next class. Then call structures and unions, then goes preprocessor. This is a typical triangle of your C language. But the most important thing is the base. If you want to learn this, these are all very easy. Your problem is not here. Your problem is not in the top. Your problem is in the bottom. You are yet to understand the difference between, still I don't know. No. When you're doing level 1, you can do the level 1 problems. C drive is, I have a level 1, I have written level 1, level 2. Level 1 is up to this. Level 2 is this. And level 3 will become function. Level 4 will become this ones. Like it goes like that. Okay. Once you do the 35 problems, you try to do level 1 and level 2. You make sure that you solve more problems. Okay. That's a way we have to grow. The more you do the problems, the more you get to know the practice. So there is this. We can start discussing about this arrays and strings more and more. But suppose I'll give you a small. I'll show you something very tricky here that you will understand now. Then you will understand how to use that very effectively. Sorry, I'm showing one thing. Now you hear, I am doing a small thing here. I want to print only welcomes you. I don't want it to print Ethan welcomes you. Now I see here, and A of 0, 1, 2, 3, 4, 5. I'm putting 5 here. See here. I'm putting the address 5. I ask him to start. Now you see here what I'm getting now. Now you see here what I'm getting. No compiler error. It's everything is fine. Now I execute it. See, welcomes you. Because I gave this printf starting address is this 5th one. Okay. Do you understand? Maybe confuse you. Am I right? Now what happened? In the memory, ECEN welcomes you. Everything is there. But to printf, I've given this address because this is 0, this is 1, this is 2, 3, 4, this is 5. See here, I've given the address of 5. He prints only that. Okay. Like that, you can take only here also. Now you see here, I have one more array. Now you see here, I declare one more array, character B of 8. Yeah, that is what the percentage is. It automatically increment. It's not how. That's a printf does. When you give a percentage yes, the printf automatically increments the address one by one and print it till it gets 0. That's the way the printf is working. Now I say for I is equal to 0, I less than 8. Am I right now? So welcomes is having how many characters? 8. I add 9. So I declare 9 now. Now what I am doing now, see that. Now it's a trick. Now you have to understand that how I am doing now. I say B of I is equal to A of I 5 plus I. Understand? Now 5 means I'm taking only welcome. How many characters? 8 characters. After completing this, I say now here B of 8 equal to 0 because I told you string should end with 0. Now I've written a small program now. I've written a small program. I am taking only from here. I am transferring these 8 characters to the another array, B. Now I'm going to print B. Now you see, now let us compile it and run it. See, welcomes, alone comes. You understand now? Now, because I've taken only the 8 characters to this, not everything. Okay. Is it clear? If you don't understand this, ask me. I've written a small usage of how do I take only one string from a Eason welcomes you. I take only welcomes and I printing that. No, if you see the code is here, I'm taking Eason. I have another array. I have 2 arrays now. I have 2 arrays. I have 2 arrays in memory. One is A array, other one is B array. So from the 5, I'm moving to 0. I'm copying this. Only 8 characters because I do I is equal to 0 to 8. The problem is these are all you will understand only once you have done the basic level of programming. Unless otherwise you do the basic level of programming, you listen to this n number of times, you will not understand. That's the problem. That's why I always say that C programming has to be priority, then come to the C language. Now I copy these 8 characters into this. Then I print from the beginning of B. That's why I written here B. When I give B, it's meaning that start of the array. So it welcomes and I end with 0. You see here, I put B of 8 is equal to 0. If I don't put this now, let us say that I remove this. By mistake, I don't do 0. Now let us see what I'm getting. Yeah, because I've already done the same memory is saved there. So that's a problem. Now I say here some other address. 10, 9. Let's see now. So it's fine. Now it's taking the end as 0. Somehow is that is not allocating anything else. So this is what sometime what happened, you will get confused how that the guy is memory is there. But in this case, the memory is 0. Even though I have not put 0, the memory is 0 actually allocated. That's why the problem is coming. So this is all quite random. It's quite random that it's a very probability wise. It's a very random. You don't know. The string end with 0 is a must, which you cannot. You're supposed to write this. Otherwise, nobody will accept the code. When you're on an interview everywhere, you should always make sure that end the code with 0. Otherwise, it's not a string. People think that you don't understand this string concept. You have to prove it to the people that you understand string. That's very important. Yeah, P of 9. Yeah, it's 0 to 8. Yeah, I've declared 9. 0 to 9. Yeah, 9 means 0 to 8. Oh, 1 minute. Once again, there's confusion. When I say B of 9 means, see, when I say B of 9, the system allocates, see here, when I say B of 9, the system allocates B of 0 to B of 8. Now, I copy welcomes here. Eight locations, 0 to 7. And 8, I make it 0. Now I make a string. If you don't write the 0 here, then it's not a string. If you don't write the end of character as a 0, it is not a string. No, I'm copying only 8. 0 to 7 only I'm copying. I'm not copying the 0. I'm not copying 0 because I'm copying only welcomes. And this is not 0. Please understand. The space is not 0. That is a character called 32. The space means 32. That is not 0. Yeah, correct. Whatever you copy, whatever you can copy, but it doesn't matter. As far as C is concerned, whatever you copy doesn't matter. Whatever character you fill doesn't matter. The end should be 0. If you don't, if a group of character does not end with 0, that is not called string anymore. Sorry.